Hi, welcome to Fetch, where we reward consumers for shopping their favorite brands. Collect your receipt and scan with our app for iOS or Android. You will receive points for scanning and lots of points for buying the brands you like. The points can be converted to gift cards at Amazon and other retailers, debit cards, and lots of other cool things. Last year, we have converted 123 billion points for the total of over $123 million from the snapshots of over 2.4 billion receipts. Fetch is a permanent fixture at the top charts in App Store. Each receipt may only be scanned once, but sometimes we get multiple scans of the same receipt. We need to detect this so we can reward our users correctly for each unique receipt. Since no two scanned receipts are quite the same once they are scanned, precise matching is of limited use, and so AI to the rescue. We reframe the problem as that of semantic search, where given an example, we want to find only things that are so close they're actually duplicates. While there are lots of methodologies available, we'll solve this problem using receipt text and applying graph neural nets to the task of semantic search. Semantic search can be trained in a supervised as well as unsupervised way, but we start with the former because we happen to have labeled examples. We are going to arrange our data into graphs. Graphs are expressive and versatile and should work just great to represent our data. We create our graphs based on how the model will be used at inference time. When a scan comes in, we will try to find the match for it in some subset of existing data. The confidence of our possible matches will determine whether the current scan is a duplicate. Our raw data comes in three parts: image files, OCR of these images saved as text files in JSON format, and a collection of duplicates, where each member is a list of file names representing duplicate scans. Although not strictly necessary, I find it convenient to store this raw data as a Hugging Face image folder dataset, so I can take advantage of Hugging Face API and easily upload it to a repository. This way, I have my data follow me wherever I go. The data we are training on is receipt text. We first extract features from each scan using a tokenizer. We limit our token sequences to 512, truncating or padding wherever necessary. Then we create our graphs. For each list of duplicates, we pick a single node and connect it with directed edges to the rest of the duplicates in the same list. Then, we sample the same number of nodes as there are connections from the rest of the dataset and connect them to this seed central node as well. We then label these edges depending on whether they connect duplicate or non-duplicate receipts. We repeat this process for all the nodes in this list of duplicates. We save a list of these graphs, and this is our dataset. And so our semantic search for duplicates becomes a link prediction problem as expressed in the GNN world. We will take a contrastive learning approach and we'll train a GNN to embed our nodes in a way that would move very similar nodes very close together and apart from dissimilar nodes in some high-dimensional latent space. We will use triplet loss to accomplish this. Triplet loss has a distance metric at its core, and so our metric at inference time will be Euclidean distance. Given two nodes on the graph, we will connect them with a positive edge if they are sufficiently close together. Thus, our neural net consists of the embedding layer, for which we reuse the embedding layer of Distilbert, An encoder, which is a graph neural net composed of two convolutional transformer layers, and triplet margin ranking loss as the objective function. We have trained and run hyperparameter optimization on AWS SageMaker on 100,000 lists of duplicates for the total of 320,000 actual receipt scans. We have achieved very high precision on the test set of 37,000 receipts, representing 10,000 duplicate clusters. Like I said before, we need to detect duplicate receipts so we can correctly reward our users. In this spirit, precision is going to be more important to us than recall. In other words, we prefer to have a high confidence that if a receipt has been identified as a duplicate, it is indeed a duplicate, and we are willing to pay the price of having a few actual duplicates slip through to achieve this. Can we improve on our current solution? What about a projector head attached to our encoder to turn this into a binary classification problem? Or using data augmentation to generate our own duplicate receipts and turning this into a self-supervised problem? What about online hard mining for difficult examples? There are quite a few things to try, so learning never stops.